Alright, for section 15.1, it's a little bit different. We're not really going to be graphing as much. We're solving equations with exponents. So we're still dealing with exponents in Module 15, but we're more looking at solving the equations and how we solve them. So that's what the EQUAT says. How can we solve equations involving variable exponents? So I've put in 5 examples up here that I think you guys could reason through pretty easily. So I'd like you to pause the video and try and complete these to the best you can. And then I'm going to be going through the answers once you play the video again. Alright, you should have paused the video and already tried these. So 2 to the x equals 4. So what you can think in your head is what value needs to go in for that x to make this equation true. Okay, hopefully you guys can figure out that that's a 2. But if not, what we can do is we can try and write our 4 as a number with a base and an exponent. So 4 we know could be written as 2 squared, which means that our x equals 2. Okay. Down here, 3 to the x equals 27. Hopefully you can figure out what that equals, but if not, we're going to think, well, how could we write 27 with a base of 3? It's 3 times 3 would be 9, times 3 would be 27. So it's 3 to the 3rd power, which means that this x equals 3. Okay? For this next one, 2 to the x equals 8. 2 to the x equals 2, and now let's see, 2 raised to what power? 2 times 2 is 4, times 2 is 8. So 2 to the 3rd power, which means that x equals 3. Okay? 4 to the x equals 16. So 4 to the x equals 4 to the, so 4 times 4 is 16, so 4 squared. So there we have x equals 2. Alright, and for the next one, 5 to the x equals 5 to the 5 times 5 is 25, times 5 is 125. So 5 to the 3rd. Hopefully you can get this answer. That means x equals 3. Alright, so we're going to look at a couple, this is essentially what you're going to be doing, it's just going to get more complicated. Right, so we're going to be looking for variable exponents. So the first way we're going to do it is we are going to look at a table and see if we can identify our answer from a table. So if I give the equation 3 times 2 to the x equals 96, what we're going to do is we're actually going to make this right here, 3 times 2 to the x, we're going to make a table for this with inputs and outputs, and we're going to see when does it equal 96, right? That's going to be our question. So for our table, just like always, it's going to be an x, y table. Alright, our x's, I'm going to stick with the same x's. No, I'm actually not. I'm going to go 0, 1, 2, 3, 4, and we'll see if we need to keep going up or not. Right? So if I plug a 0 in, I'm going to get out a 3. If I plug a 1 in, 3 times 2 to the 1, 2 to the 1st power is 2, times 3 is 6. Notice what I'm multiplying here by 2. So the next one I'm going to get 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. Notice also multiplied by 2. So let's just keep multiplying by 2. 24 times 2, 48. We're not quite to this 96 yet, so let's keep going. 5, 6, 7, multiplied by 2, 96. Multiplied by 2, 192. Okay? Yep. Okay? So what we were looking for in this table, 3 times 2 to the x, is when does it equal 96? Well, that's right here. So our answer to this would be x equals 5. Right? That's our answer from our table. Okay, but without looking at the table, let's do something algebraically. Let's solve this equation algebraically. So 3 times 2 to the x equals 96. Alright, to solve this, we always need to isolate the term that has the x in it. Okay, we always need to isolate the x. Well, this 3 out in front is just being multiplied right now. So in order to do inverse operations on that, we could just divide both sides by 3. And we get 2 to the x equals, let's see, 96 divided by 3 is going to be 32. Alright, and then now we have 2 to the x. We actually can't separate those because the x is in the exponent. So we're going to go 2 to the x equals 2 to the, and we're going to go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power, which means that our x equals 5. Okay. So 2 ways that we could do it. We made a table and we solved x equals 5 from the table, or we can solve it algebraically. I personally definitely prefer algebraically, so that's how we're going to solve the rest of the equations, is algebraically. It's only going to be about 4 more. Alright, so 5 times 2 to the x equals 160. In order to solve this, that first 5 is just 5 times 2 to the x. So we can always use inverse operations and divide it. So we get 2 to the x equals 20 plus 12, so 32. 32. And we actually just solved basically this exact equation. So x equals 5. Okay. I'll do one more kind of simple one with you guys, and then I'll let you guys do a little bit more complex of one, because we're definitely going to get into some ones with fractions, which you guys are not going to like as much. So 7 times 3 to the x equals 63. Alright, when we solve this, this is 7 times. So in order to cancel out that 7, we use inverse operations and divide by 7. You get 3 to the x equals 9, which means 3 to the x equals 3 to the, 3 times 3 is 9, so 3 squared, which means x equals 2. Okay? Alright, so the 2 that I would like you to solve on your own . So these ones will be on the left-hand side. Of course, feel free if you need a calculator, you can of course go grab a calculator. Alright, so go ahead and solve those 3 on your left-hand side, and when you're done with those, go ahead and come back, and we're going to do some fraction stuff. Okay, you should have already solved these 3, and now we're going to move into doing some with fractions, which are going to be fantastic. Okay, the first one, 2/5 times 5 to the x equals 250. Okay. So similar, right, to what we did before, this is still 2/5 times. So in order to get rid of that 2/5, we are going to just divide both sides by 2/5. But since it's a fraction, and I don't like dividing by fractions, I'm going to do multiply by the reciprocal. Okay, 5 over 5, those cancel. 2 over 2, those reduce to 1. So 5 to the x equals 250 over 1. Okay, we're going to multiply those together. 250 times 5. It's going to be a big number. 250 times 5 is 1250 over 2, which means 5 to the x equals 625. Okay, which means that we need to figure out 5 to the x equals 5 to the something power. So 5 times 5 is 25, times 5 is 125, times 5 is 625. So 5 to the 4th power, which means that that x equals 4. Okay? And remember, if you can't do the multiplication real quick in your head, you just go in your calculator and go 5 times 5. Go 5 times 5 times 5 times 5 times 5 until you get the number you need, right? So you can also do it in the calculator just to check yourself if you're not so great with that mental multiplication. Okay, couple more. Actually, I want you to do this one on your own. So 2 over 3 times 3 to the x equals 18. Okay, do that one on your own on the left-hand side, and then pause the video, come back when you're done. Alright, so you're back with me. You should have already solved this. You should know what x equals. Okay, so now let's do stuff with fractions as the base of our exponent. Okay, so here we start off a similar way, right? That 5 is being, or that 2 is being multiplied. In order to cancel it out, we have to divide by 2. Right, divide by 2. Well, this is kind of funky looking, so instead of dividing by 2 over 1, right, because that's 2 over 1, let's multiply by the reciprocal, because that's just way too messy for me. So instead of dividing by 2 over 1, we're going to have to multiply, right, because 2 over 1, same thing as 2. We're going to have to multiply by 1 over 2 on both sides. Okay, the 1's cancel, the 2's cancel. We are left with 5 over 3 to the x equals 250 over 54. Okay. And let's see if we can reduce this at all, because when I'm looking in my head, I'm thinking, there is no 5 to the x power that goes into 250. So let's think about how we could reduce this. We could divide both of them by 2. So let's try that. If we divide the top by 2, we get 125. And the bottom by 2, we get 26. 27. Okay. And now let's think. So now we have to rewrite this as them having the same bases, so 5 over 3. And now we're thinking about what exponent. So 5, let's check 5. 5 times 5 is 25, times 5 is 125. So I'm thinking the exponent is probably 3, but let's check the denominator. 3 times 3 is 9, times 3 is 27. We're good. Okay, so that means that our x value right here is equal to 3. Okay, and last one, I'll give you one to do, and then you will be done with these. Okay. Fractions galore, because I know you guys love fractions. 3 over 2. Okay, so same as before, this is the first thing you have to undo. The first thing you need to use inverse operations for, because multiplication. But instead of dividing by a fraction, we're going to multiply by the reciprocal, which means 2 over 3. And whatever we do to one side, we have to do to the other side. These 2's cancel, these 3's cancel. We get 4 over 3 to the x equals 16 over 9. Okay. We can't simplify that fraction at all. So we're going to try to write this with same bases. So 4 over 3 to the x equals 4 over 3 to the something. So let's check the numerator. 4 times 4 equals 16. Okay, looking good so far. So we think the exponent is probably 2. Let's check the denominator. 3 times 3 equals 9. There we go, the exponent is 2. X equals 2. Alright. You're going to have one to do on your own with some fractions, and then that's going to be it for this. Probably definitely going to need a calculator for this one. Okay, that's on the left-hand side, and that's the last part of this video.